All right, here we go, friends. Let's practice converting scientific notation numbers into standard and standard into scientific notation. So first, I'd like to go over taking a standard form and converting it to scientific notation. So there's a couple steps we're going to follow. First, we'll move the decimal so that it is between the first and second non-zero digits. We'll count the number of times we moved places. This is the value of the exponent. If the original number is large, meaning it's above 1, the exponent will be positive, and if the original number is small, meaning less than 1, the exponent will be negative. So I'll go over these first two, and then I'd like you to pause and do the we do problems. So we have 5,700.3. We're going to take this decimal, and we're going to move it to over here between the 5 and 7. And we're going to rewrite everything, including the zeros. Now when we did that, we moved it 1, 2, 3 times. So our exponent is 3. So we should get 5.7003 times 10 to the 3. And the reason we know it's a positive 3 is because this is a big number. It's much larger than 1. Let's take a look at this other example. We're going to move this decimal so that it's between the first and second non-zero number. So we're going to go 1, 2, 3, 4 times, so it's right there between the 4 and the 3. Now all these zeros out front don't matter. We can get rid of those. But if zeros are in between stuff, we got to keep them. So we're going to rewrite that as 4.32 times 10 to the negative 4. And the reason we know that this is a negative 4 right here is because this number is super duper small. It's much less than 1. Okay? So there are two examples of converting standard notation into scientific notation. I would like you to pause here and do these two we do numbers. Okay, welcome back. Let's look at the solution for these two we do's. Now this first number, 7,980,000, the decimal is way over here. It's not shown, but it's implied to be on the right side of that number. So we need to move it 1, 2, 3, 4, 5, 6 places. So when we rewrite that, that's 7.98 times 10 to the 6. And it's a positive 6 because this is a huge number, much larger than 1. The other number, right here, we're going to move it 1, 2, 3, 4, 5, 6 places. So that's 2.1 times 10 to the negative 6. That's a negative. I don't know why it's an underscore there. And the reason it's negative is because this is a tiny number. It's a lot smaller than 1. All right. Now we can take those scientific notation numbers and convert them into expanded form. And the steps we're going to use to do that is to move the decimal, the number of places, according to the value of the exponent. If the exponent is positive, we're going to make it a large number, greater than 1. If the exponent is negative, we're going to make it a small number, less than 1. So let me do these two I do problems. Here's 2.75 times 10 to the negative 4. So I've got the decimal here. I need to make this a small number. So I need to figure out which way I'm going. If I go this way, the number gets bigger. Right? If I move it once, that's 27.5. If I move it again, that's 275. Those are big numbers. Negative exponents mean small numbers. So I'm going to move it 3 places to the left. And everywhere I leave a space, I have to have a 0. So that's going to end up being 0 and then my decimal. And notice I went 1, 2, 3, 4 places. And I put a 0 in all those blank spots. So 0.000275. And look, we can check. Negative number, small number. Right? Negative number, small value. Let's do the same thing but with our positive exponent here. So we're going to take our decimal and we have to move it 7 places this time. And it's positive, so we want a large number. So if we go to the right, if we move it once, it becomes 31.4. If we move it twice, 314. But we've got to move it 7 total times. So our number would be 31,400,000. So the decimal was here, and we went 1, 2, 3, 4, 5, 6, 7 places. And I moved it this way because this is a huge number. I knew the exponent was positive. I needed to make a big number. 31,400,000 is huge. So let's take a moment to pause the video and do these two we-dos. Okay, welcome back. Let's check out the solution. 7.99 times 10 to the negative 3 has a negative exponent, so we need to make a small number. So we need to move our decimal this way. And the solution we get is 0.00799. The decimal was here. We went 1, 2, 3 places. All right. 4.04 times 10 to the 10. That means we need to move our decimal 10 places. And that's positive, so we want to make a big number. So let's move it to the right. We started here, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get 40,400,000,000, a really big number. And we know it's supposed to be big because the exponent is 10. Now, a way you can check yourself when you're doing these problems is to take that scientific notation number and type it into your calculator. And you should get the answer that you chose, right? If you type this one in, you're going to get that number. If you type this one in, you're going to get that number. Now, some calculators only have so many digits across the screen that they'll show. So if there's too many digits, they'll automatically put it in scientific notation. So when the exponents get really large values like 10 or 15, or we're going to see to the 23rd power later this semester, those won't change. But if you're doing this for the most part, it should display the expanded form or the standard notation when you type in the scientific notation. All right, bye-bye.